So in this video, we're going to go through sample question 31 from the Society of Actuaries ExamP list of sample questions. The question reads, a company establishes a fund of 120 from which it wants to pay an amount, C, to each of its 20 employees who achieve a high performance level during the coming year. Each employee has a 2% chance of achieving a high performance level during the coming year. The events of each employee achieving a high performance level during the coming year are mutually independent. All right, so the beginning of this question is very wordy already. We're finally asked to calculate the max value of C for which the probability is less than 1% that the fund will be inadequate to cover all payments for high performance. So this is a great question for, studying a few different things. One, this question isn't directly telling us what we need to do. We need to figure that out. So it's saying the max value that it wants to pay to C, that it wants to pay to each high-performing employee without, with a less than 1% chance that the fund will be inadequate. So when will the fund be inadequate? Well, it'd be inadequate if too many people become a high-performing employee. So the likelihood of a certain number of employees achieving that high performance level is directly related to the probability that the fund will be inadequate, right? So we need to figure out the probability, essentially, of of how many employees it would take of achieving a high performance level, where that likelihood of that event happening is less than 1%. All right, so let's look at the probability of a certain number of employees achieving a high performance level. So if we look at a specific employee, a specific employee has a 2% chance of achieving a high performance level. But we're not looking at a specific employee. We're looking at a batch of employees. There are 20 employees in this company. So what is the probability that any one of them has achieved high performance? It's not 2%. This is an example of a binomial distribution, right? This and a Poisson distribution are the two discrete probability distributions that you really need to be familiar with. I mean, there are a few others, but I mean those as they are the most common. You should also be familiar with uniform, hypergeometric, geometric, negative binomial, multinomial. But binomial and Poisson are the two most commonly occurring discrete distributions. Okay, so let's go about actually calculating these probabilities. So the probability of getting exactly 0 employees. So the probability of x equals 0. Right, and I should probably write this should be something you have memorized, but the probability that any x equals a specific value of x for a binomial random variable is n, the number of trials you're conducting, choose x, multiplied by the probability of a success raised to the x power, multiplied by the probability of a failure raised to the n minus x power. In this case, we're considering a success being an employee being a high performer. So this is equal to 20 trials, 20 employees. We're looking at the probability of exactly 0 multiplied by the probability of a success, which is, in this case, 0. The probability of success should be 0.02, right? So multiplied by 0.02 raised to the 0 power, multiplied by how many failures? Well, there's a 98% chance of failure, so 0.98 raised to the 20th power. All right, now just give me a moment to put that in my calculator, and that's going to be 20, choose 0 multiplied by 0.02 raised to the 0 power multiplied by 20 minus 0, or multiplied by 0.98 raised to the 20 minus 0, which is just 20. And there is a 66% chance, 76.7607, right? It's a long out decimal, so it's approximately a 66.76% chance of occurring. So that's not up to 99%, right? So now let's check out the probability of exactly one employee getting this, and that's going to be 20 choose 1 times 0.02 raised to the first power times 0.98 raised to the 19th power. Okay, and that's going to end up being 0.27249, and continuing and so on. So the probability that either 1 or 0 employees is a high performer is the following, like just the sum, 0.940101022. So we're not up to, that 99% mark that we're looking for. So now the probability of getting x equal to 2. And I compute the exact same probability. Okay, and that's going to be, let's see, 20 choose 2 multiplied by 0.02 to the first power, to the second power times 0.98 raised to the 18th power, and that's 0.05280302. And in order to get the the CDF, I just have to add it on to my previous total, and that's equal to 0.99.293. So at this point, we've passed the 1% mark. Okay, so there's less than a 1% chance for more than 2 employees to achieve high performance, right? So therefore, we must conclude that the choice for payment C should be split up amongst 2 employees. Like less than 1% of the time will more than 2 actually be a high performer. So 120 divided by the 2 employees gets us the max value of C, which is going to be 60, right? Because let's look at this. If each payment was 60, what's the probability that I'll run out of money? Well, that's the probability that more than 2 employees are able to become high performers. And that is less than a 1% chance. And that lines up with answer choice D. Right? Hopefully that was clear. This question was a couple of different things, right? You have to be able to just decipher the problem. It doesn't directly talk about the likelihood of employees, like how many employees getting high performer. It relates it to the cost of a fund that pays out to employees. And another thing this thing tests on is the binomial distribution, knowing its probability function. And those 2 concepts are going to be very key to doing well in ExamP. If there are any questions, you can leave it down in the comments. I'll answer to the best of my abilities. If this video helps you out, hit the like button, because that definitely helps me out. And if you want to see more videos on worked out problems, I have a playlist. Right, so go check that out. But other than that, good luck, guys.